everyone. As you know that we have not finished the curriculum, but don't worry about it. Other classes are like us as well, and your teachers next year will be able to accommodate that. So for this week, I just want to talk about the basics of proportional reasoning. Okay, let's talk about similar figures. Similar figures are the figures that have the same shape but with different size. If they have the same size, then they're going to be exactly the same. So let me give you guys a few examples about what similar figures are. So let's say I draw something, uh, a heart. So if I enlarge it uniformly, or if I make it smaller uniformly, then these three shapes are similar to each other, right? Because they are of the same shape, but they are different sizes. Now, what if what if I what if I enlarge it like this? Will this shape and the original shape be similar? It will not, right? Because the original shape, this one, and the new shape, this one, these two are not of the same shape. So they will not be similar figures. Now let's go back. What are the properties of similar figures? Two figures are similar if their corresponding angles are the same and their corresponding lengths are proportional. What does proportional mean? Proportional means that their ratio are the same. Uh, their ratio are the same. We can see similar figures everywhere through our life. For example, the world map or the drawing of an animal cell or model of a car, things like that. If you take a look at of this world map here, this map is a reduction of the actual world, right? It's so much smaller than the world. So this is a reduction. Now consider the drawing of the animal cell. Do you think it's an enlargement or a reduction? So just compare the actual animal cell and the drawing of the cell. Is the drawing bigger than the actual cell or is it smaller? We know that the cells are really small, and a drawing like this will be much bigger than the actual cell. So this is called an enlargement. Now, we know the map is a reduction and the cell diagram is an enlargement. But how do we calculate how much they're enlarged or reduced? We'll be able to calculate that by calculating what's so-called the scale factor. Okay, scale factor is how much the object is enlarged or reduced. Okay, and it's calculated using this formula here. Scale factor is equal to the image length divided by the object length. Okay. If your scale factor is greater than 1, then it's an enlargement. So scale factor is greater than 1, then it's enlargement. So what about reduction? Reduction is when the scale factor is between 0 and 1. Okay, this makes sense, right? So let's say your object is, uh, 5 centimeter long, and the scale factor is 2. Then 5 times 2 will give you the size of the image, which will be 10. Then the image is 10 centimeter long. If you compare 10 centimeter to 5 centimeter, it's enlargement. If my scale factor is, let's say, half, which is 0.5, then 5 times 0.5 is equal to 2.5. And 2.5 comparing to 5 will be a reduction. Okay, so to enlarge your object, you have to multiply by a number that's bigger than 1. To reduce your object to a smaller size, you need to multiply by a number that's between 0 and 1. What do you think if the scale factor is 1? What would it be? If the scale factor is equal to 1, then what would you have? The object and the image are the same. There's no enlargement or reduction. You have exactly the same thing. Okay, let's do an example together. Fill in the blanks on this table. So let's do the first one first. The first one, it tells you the object length and the image length and asks you to find the scale factor. If you still remember, the scale factor is equal to the image divided by the object. So this one is easy. Image is 5 and object is 25. So 5 over 25 will be 1 over 5. And just so you know that scale factors will not have any unit. As you can see here, centimeter and centimeter cancels each other, so the scale factor don't have any unit. Okay, next question. Tells you the image length and the scale factor and asks you to find the object. How do we find it? Again, we'll be using the formula as well. Scale factor equal to image over object. We know the scale factor is 0.1. We know the image is 10, but we don't know what the object is. I'm writing object here because O looks like a 0 there. So to find object, I'll need to multiply the object on both sides and divide by 0.1. Or if you guys want, you can use cross multiply. So we know 0.1 times the object is equal to 10 times 1. So the object is then equal to 10 divided by 0.1, which is equal to 100. And this time it's the object length, so it will have a unit, okay, which is centimeter. Okay, last question. Given the object length and the scale factor, ask you to find the image length. Same thing, we'll apply that formula. Image over object. Object is 65. Scale factor is 0.2. Image we don't know. And to find the image, This one is easier. We just need to multiply 65 on both sides. So we know then image is equal to 0.2 times 65, 13. So 13 centimeters. Make sure you add the unit. And let's see if these make sense. So for the first row here, the object is 25, image is 5, so we know it's a reduction. And the scale factor here, 1/5, which is 0.2, it's between 1 and 0. It's between 0 and 1. So this one makes sense. What about the second one? The second one, the the object is 100, the image is 10, so we know it's a reduction again, and the scale factor here is 0.1 between 0 and 1, so a reduction makes sense. Last one, again, object is greater and image is smaller, so your scale factor will be between 0 and 1. So every time after you've done a question, better check if the image size or the object size or the scale factor makes sense. All right, next let's talk about similar triangles. Recall that two polygons are similar if their corresponding angles are equal and their corresponding lengths are proportional. But similar triangles are a special case of similar polygon. Okay, it doesn't have to satisfy those two conditions in order to be similar. The only thing that it needs for two triangles to be similar is that if the two angles of one triangle is equal to the two angles of another triangle, then these two triangles are similar. In short, if two corresponding angles are equal, then the two triangles are similar. Okay? But the reverse always hold. So if two triangles are similar, then it follows that the three corresponding angles are equal and the three corresponding lengths are proportional. Now, let me explain to you why similar triangles is a special case of similar polygons. If you guys take a look at these two triangles, the question tells you that angle A is equal to angle D and the angle C is equal to angle F. And we know that the three angles of a triangle will add up to 180 degrees. So if the two are the same, that means the third one must be the same as well. And for triangles, if the three corresponding angles are the same, then the shape is fixed. You won't have another shape. Okay, the shapes are always the same if the three angles are the same. It's different though for polygons. Let's say if we take a look at these two figures. If the question tells you that these two angles are right angles and these four angles are right angles as well, then we know the four corresponding angles are all right angles. They're all equal. But do you think that these two shapes are similar to each other? No. One of them is a rectangle and the other one is a square. They're not similar. So for polygons, you would always need to make sure that they satisfy both conditions so that the angles, the corresponding angles are equal and the corresponding sides are proportional. If they don't satisfy both, then you might happen to end up with a situation like this, where all the angles are equal, but then they're not similar. Okay? And just so you know that the symbol for similar figures is the squiggly sign. So if we say that these two triangles are similar, we'll use a squiggly sign here to represent that they're similar. So if the question tells you two figures are similar, then we can reach to some conclusion. For example, if the question tells you that triangle ABC is similar to triangle DEF, then we know that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. This is the part where it says the corresponding angles are equal. And we have a second part, that is the corresponding sides are proportional, right? So we know the corresponding side for AC is DF. So AC over DF will be equal to the other two ratio of the corresponding sides. So the corresponding side for AB is DE. So AB over DE. And this is also equal to BC over EF. Okay, so this is the part where the corresponding sides are proportional. The corresponding side for AC, this one is DF. So AC over DF gives you a ratio that is the same to the ratio that the other corresponding sides gives you. So AB and DE will give you another ratio, and BC, EF will give you another ratio, and these three ratios should all be the same if the two triangles are similar. Okay, let's do a few examples together. First example, the question asks you to determine the length of x and y. Given the question here, we can see that there is a squiggly sign. What does it mean? It means that the two triangles are similar. And we know that if the two triangles are similar, then the corresponding sides are proportional. So if we can find the corresponding sides and set their ratio equal to each other, then we'll be able to find the missing values. Okay, so from the question here, we can see that the corresponding side for 2 is 6. So we can write down 2 over 6 equal to, let's do x first. What's the corresponding side for x? It will be the 5, right? But which one do we write on top? Which one do we write on bottom? You need to make sure that you write the same, you write the sides of the same triangle on the same sides. 2 is the sides from the smaller triangle and it's on top, then 5 should be on top as well because they're all from the same triangle. And x is from the same triangle as 6, so it'll be on the bottom. Now to calculate x, we just need to cross multiply. So 2x is equal to 5 times 6, and 2x equal to 30, so x is equal to 15. Okay, to find y, we'll use the same idea. So 2 over 6 again is equal to, the corresponding side for y is 7. And 2 is on top, so 7 from the same triangle as 2 will also be on top, 7 over y. And cross multiply, 2y equal to 6 times 7, 2y equal to 42, and y equals to 21. Okay, another question. The question asks you to calculate y given this diagram. So in order to calculate y, we need to make sure that the two triangles are similar. But does the question tell you that they're similar? No. It didn't say in the question that these two triangles are similar. So we can't use the property yet. Therefore, we need to prove the two triangles similar in order for us to use the property that the corresponding sides are proportional. Okay, so how do we prove that they're similar? Remember that if two corresponding angles are the same in two triangles, then we can conclude that the two triangles are similar. And the question tells you already that these two angles are the same. We just need to find another pair of angles, um, then we'll be able to prove that they're similar. Okay, so which pair of angles can we find that are the same? We can find this angle and this angle. These two angles are opposite angles. Okay, if you don't know that opposite angles are equal to each other, we can prove it here. So let's say my red angle and this is my blue angle. The red angle, angle DCE, plus the blue angle, angle BCD, this is equal to a straight angle which is 180 degrees. And this angle here is angle ACB. Angle ACB plus angle BCD is also equal to 180 degrees. Now, these two angles are the same angle. So if two angles plus the same angle both equal to 180 degrees, then for sure that these two angles will be the same. So angle ACB is equal to angle DCE. Therefore, we have two sets of conditions, angle B, angle E equal, and this black angle and this red angle equal. So we can prove that triangle ABC is similar to triangle DEC. Now you guys might wonder why I use DEC, not CDE. The reason is that I would like to have the corresponding angles in order. So we know angle B and angle E are the same, so angle B and angle E are both in the middle. And we know angle ACB and angle DCE are the same, so both of these are at the end. And for sure, then angle A and angle D are the same. So we have the corresponding angles in order. It makes it easier for me to find the corresponding sides. Okay, so now let's move on. Now that we've proved that these two triangles are similar, we can use the property of corresponding sides to find y. Let me use another color. So y is this side. This side is side CD. And what's the corresponding side for CD? It will be AC. Well, if you guys can't find the corresponding side on the diagram here, you can look at this statement here. We know y is the side between C and D, so CD, and so its corresponding side must be between the two corresponding angles as well. And we know the corresponding angles are A and C. So then the corresponding side must be AC. So you see that CD is C and D, the side between these two angles. So the corresponding side must be between A and C. Okay, now we can write down the equation. So we know CD is corresponding to AC, which is 5. So this must equal to, and another side we can use here is 10. We can only use 10 here. And 10 is in the same triangle as y, so it will be on top. And the corresponding side for 10, 10 is CE. 10 is CE. CE between these two angles, so the corresponding side will be BC. BC is right here, which is 6, 10 over 6. Okay, and I should write y here instead of CD. Okay, now we can do cross multiply. So 6y equals to 5 times 10, and y equals to 5 times 10 is 50, 50 over 6. Or you can do 25 over 3. So to do questions like these, where the question didn't tell you that they're similar and asks you to find the missing side, what you need to do is you need to prove that the two shapes or the two figures are similar first before you can find the missing sides. Okay, so prove it similar first and then find the missing sides using the property of similar figures. Like I said, similar triangles is a special case of similar polygon. So if you know how to do questions for similar triangles, you should also be able to do questions for similar polygons. Except that when you are proving for similar polygons, you need to make sure that you have all the angles equal and all the corresponding sides proportional. Okay, so you can try the questions in your workbook for similar triangles and similar polygons. And if you have any questions, please let me know. I'll be very happy to help you with your questions.